So we're still looking at writing equations of ellipses instead of having a graph this time. However, you're given certain information. So we still have our different standard forms, okay, where A is your larger denominator. Okay, so A has to be the greater number and B is a smaller denominator. Okay, that determines whether it is horizontal or vertical. Your foci points, you need to find what C is for those. Your vertices will help you find A, and your co-vertices will help you find B. Okay, so we want to write an equation for the ellipse with vertices at -6, -2, and 4, -2. So what I do given that information, put it away. What I do given that information, I look to see if my x values are the same or if my y values are the same. Okay, my y values here remain the same. So if I look where it says vertices in my table, I want to see where the y value doesn't have anything added or subtracted to it. Okay, that would be this one right here. Okay, so your y value is k. There's nothing added or subtracted, so it stays the same the entire time. Okay, that means this is a horizontal ellipse. If I were to go over here, I see that my y value in that coordinate has a plus or minus a. That means that these two numbers would be different from each other. So I'm using that it is horizontal since my y value remains the same. Okay, it is horizontal. So that means I'm in the form x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So my first step after that is to find the center. Now, just like with circles, to find that center point, we have to use the midpoint formula. Okay, so I am going to use that midpoint formula. And that's x sub 1 plus x sub 2 divided by 2. And y sub 1 plus y sub 2 divided by 2. So average your x's, average your y's. It doesn't matter if you use co-vertices or vertices, I'm just going to use the vertices. Okay, so here with my vertices, I want to average my x's. So I'm going to add -6 plus 4 and divide by 2. Same thing with my y's. I have -2 plus -2 divided by 2. Okay, I have -6 plus 4, that is -2. -2 divided by 2 is -1. -2 plus -2 is -4. -4 divided by 2 is -2. Okay, so this is my center point, and your center of your ellipse is at HK. So now I found H and I found K. The next two parts I need are A and B to write out this equation. So I found H and K, I still need A and B. So step 2 is to find A. There are two different ways you can do this. Okay, you can use a vertice, or you could find your major axis. Okay, using a vertice, since we are a horizontal ellipse, your vertices are at H plus or minus A, K. So I know what H is, and I know what this coordinate is for my vertex, or my vertices. So if I use a vertice, I'm just going to pick one. So if I use -6, -2, right? Your K value is -2, right? Your H value is -1. So I would have to plug in -1 for H. And then that value has to equal this point. Okay, so your H plus or minus A has to equal that X value from your vertice. Now we know what H is. It's -1. So we have -1 plus or minus A is equal to -6. So add 1. So I have this plus or minus A is equal to -5. Now your A value is always going to be positive. Okay, your A value is always going to be positive. So we're just going to end up with A is equal to 5. Now if you do this with your major axis instead, your major axis is the distance between your two vertices. Okay, so if you're trying to find the distance between your two vertices, you just have to take those values that change from each one. So I don't want to find the difference between these -2's because it'll just be 0. Okay, I want to find the distance between -6 and 4. Okay, so I want to find the distance between -6 and 4. So to do that, I would just take the absolute value of -6 minus 4. So I want to find that difference. Okay, that's equal to -10, which is 10. Now that's your major axis. Okay, do you remember how to find A if you have your major axis? Your major axis is equal to 2A. Okay, so I would have 10 is equal to 2A. So again, A is 5. So these are your two different ways to find what A is. Okay, two different ways to figure out what A is. You can either find your major axis and divide by 2, or you can use your coordinate from your vertice to find A. Okay, so now that I have A, I still need to find B. Okay, so to find B, we're going to use a covertice. Okay, so we're going to use a covertice. And I'll use -1, -4. Now if I look back up at the chart, okay, we'll finish copying. If I look back up at the chart here, I know my ellipse is horizontal, so I'm using this column right here. My covertice is at H, K plus or minus B. Okay, so that's where I'm going to get B from. So we have H, K plus or minus B. So I know this value has to equal that -4. Okay, so I would have -4 is equal to K plus or minus B. We know what K is. We found that in our center. K is -2. And then we have plus or minus B. So I would add 2. To get plus or minus B. And again, your A and B values have to be positive. So this would just be B is equal to 2. And again, just like with finding A, if you want, you can find your minor axis as well. That's that difference between your two values that change in your co-vertices. So if you look at your co-vertices, you have one at -1, -4, and the other one is at -1, 0. So I want to find the difference between -4 and 0, not the negative ones. Okay, your A and B value should not be 0. Okay, so if I found the difference between -1 and -1, you would get 0. So that's not the ones you want to use. So again, we have this OR. We could take the absolute value of -4 minus 0, which is -4 to get 4. And that is your minor axis. So your minor axis, again, is equal to 2b. So I would have 4 is equal to 2b. Again, divide by 2 to get b is equal to 2. Okay, so again, two different ways to find b. You had two different ways to find a. You have two different ways to find b. Either way is correct. So now you have your center, which is at HK. You have A, that's 5, and you have B, that's 2. Okay, that's all the information that you need to plug into your standard form. Okay, so step 4 is to write the equation. Okay, so we want to write the equation. So we have x minus our h value. Our h value is -1. That's squared. And that is over our a value squared. So a is 5 plus y minus k. K is -2. And that's over your b value squared. So we'll have 2 squared. And these are always equal to 1. So we're going to make this look a little bit nicer. So if I have minus a negative, that's just adding. So we would have x plus 1 squared over 5 squared is 25. Plus, again, we have minus a negative. So y plus 2 squared over 2 squared is 4. And that is equal to 1. Okay, so find the center, find A, find B, then write your equation. Okay, those are each of your steps there. Center, A, B, right equation. Questions on that?
No. That was the pencil drawing.
Oh, was it? All right, go to the back then. Example 2. So a listener is standing in an elliptical room 150 feet wide and 320 feet long. When a speaker stands at one focus and whispers, the best place for the listener to stand is at the other focus. Write an equation to model this ellipse, assuming the major axis is horizontal and the center is at the origin. Okay, if your major axis is horizontal, that means that's your longest axis. So is 150 or 320 bigger? Okay, so our major axis is 320. And then that means our minor axis is 150. Since it's horizontal. Okay, so we're going to go through the same process. So step 1 is the center. Okay, it said the center was at the origin. What is your center coordinate then? So that's H and K. Step 2 is to find A. To find A, we're going to use the major axis. Okay, major axis is 320, and you're going to divide that by 2. Okay, step 3 is to find B. To find B, you will use the minor axis since it is equal to 2B. Your minor axis is 150. So we want to divide that by 2. To get B is 75. So this is a horizontal ellipse because it told us it was horizontal. Okay, so if you look at the front, for your horizontal ellipse, we have x over the a squared value. So for step 4, writing out this equation, we would have x minus our h value 0 squared over our a squared value is 160, and that's squared, plus y minus k is 0 squared over our b value 75 squared, and that's equal to 1. Okay, so if you want, you can keep these quantities as x minus 0 and y minus 0. You don't have to. You can write it as x squared over that 160 squared, which is 25,600, plus y squared over 75 squared is 5,625, and that's equal to 1. And that would be your answer. So sometimes it is easier just to use those axes to find your A and B value instead of the the vertices or the covertices. But it is up to you whichever way you find easier to find those two values.